one of the founder member of Integral University, Kidwai sir is there. So I hand over the mic to my respected Kidwai sir. Sir.
Welcome to all participants and our renowned speaker Rohit sir, who has been my classmate. I was fortunate to have him as classmate, I would say, and he was four members who joined immediately. He was selected in IIT MTech. He was one of them. Four brilliant students, I would say, of my class, and he has worked in many companies of software and started his own venture in 2014, I suppose, if I'm correct. And he has worked a lot in artificial intelligence, and I'm sure we all will benefit by the inputs, especially the students who want to make a career in AI. So thank you, Imran sir, for giving me a chance to welcome my friend.
Welcome, sir.
You may proceed.
Okay. Okay. So, Rohit sir is adjunct professor in California Science and Technology University, and terms Milpitas, California. So I request Rohit sir to share his valuable knowledge with us. He has vast experience of this artificial intelligence, and the topic of the Rohit sir is application of artificial intelligence in our life. So I request Rohit sir to take the chart. Thank you, sir.
Good morning, good evening, everyone from wherever you are joining me. I am based in California, so it's about 10:30 p.m. right now, Sunday night. So a little bit about me, and you see on the screen, like Professor Kidwai said, I had a pleasure of, studying with them in my bachelor's. We had a great time there, and then I moved on to IIT Delhi, and I was there in Bangalore for about a year before migrating to US back in 1999. And I came here with the idea that let me go check out the work culture for a year or two, and then I'll be back in the country. So I guess I'm still waiting for those 2 years to be over. In the meantime, I have worked for many companies, including Texas Instruments, Magma, Apache, Cadence, Purpose, and AITS. And the last one that I started was in machine learning back in 2014. That company was acquired by another one, and I started AITS in 2018. Other parts of my life, I'm generally passionate about software and technology. Anything that new shows up on the horizon, I'm very curious to learn and find more about it. It has its goods and bads. But that's my inner child that keeps me excited about the new things. I'm busy creating deep learning framework and compiler for the past 3 years, and my social handles are given on the slide for people who want to reach out to me, have a question or anything I can help out with. So feel free to reach out to me for something innovative or idea that you might have. With that, the topic of the today is Industry 4.0. Before we start, it makes sense to go back to the history, review a little bit, like in a couple of minutes, and see where we are and why is it called Industry 4.0, right? So at the end of 18th century, when steam engine came to power, pun intended, it created wave of economic disruption in the parts of the nation. So the countries who adopted that, it was possible for the economy to become nationalized. And before that, economy was intensely local, meaning you grow here, you sell here. And you could not take the produce or product from one part of the country to the other part, partly because there was no infrastructure and railroad actually created that infrastructure. So it disrupted many verticals, many industries because of the connectivity and transportation. And that was the end of the 18th century. Beginning of 20th century, electrical power and factory automation, essentially automating most of the work that human used to do before, created a second revolution, and again disruption in many industries because of that. And by itself, electricity wasn't much of an innovation, but the applications it created, starting from a bulb to the computers that we work on a daily basis, it has created immense dependence of electricity in our daily lives, and that created Industry 2.0. And in 1970s, when use of electronics and IT came into being, that was Industry 3.0. The way we live our life today heavily relies on some of the semiconductors that you are not even aware of, and that's the part of the innovation. Innovation seems to be, it must disappear for it to enhance the human life. And if let me give you an example. If you are sitting in the car today, car is a mechanical vehicle, and you would not probably guess that there might be semiconductor chip inside that car. And if you're sitting in a car, probably even in the old 2000 model, like 20-year-old model, you are sitting around 20 different chips, 20 different microcontrollers and single board computers inside inside a mechanical vehicle. And if you're using some of the normal electronics, for example, your cell phone, even your DSLR has a semiconductor chip inside. It's so in a typical household, there are close to anywhere from 200 to 500 different semiconductor chips, depending on the size and number of other things. So it has become so ubiquitous that you can't even imagine your life without it. And cell phone is a very relevant example of that. If there was no semiconductor, you wouldn't have cell phone today. And I'm not sure how many people can live without cell phone, even for a day. I can't. So that actually explains how these revolutions come to existence and what do they do to our lives. And now we are sitting on Industry 4.0, which we are watching it unfold in front of our eyes. And that is use of cyber physical systems to monitor, analyze, and automate our business. And AI is playing a key and very important role in all of that Industry 4.0. So with that little bit of introduction, let me move on to what AI is doing to the industry revolution. Like I said, the first one was railroad, second one was assembly lines, third one was digital, and the fourth one is IoT and artificial intelligence. And like everything else, for example, electricity by itself is not much of an innovation. Just like electricity, I mean, there's not much you could do by moving electrons from one point to another unless you could create applications around it. And it's the same thing with AI. And AI has applications on any branch of science, including art. For example, people are creating music. There is a music industry that is coming up based on AI. There are quite a few YouTube channels, and they're not today. Like go back 3 years. So AI is creating the music the way human used to create in the last decade. Now it is becoming seamless slowly. For example, auto-tuner has been with us for almost 2 decades. It's been frowned upon, but still part of music industry. And that is taking over some of the art skills that we human used to perform. And that's just one example. And I have a number of examples. I mean, I wouldn't be wrong if I say there are close to 1,000 different markets and verticals that AI would disrupt today. So AI is kind of new electricity and fast becoming the central tenet for the disruptive changes that we will see in the future. If there is a question, I would like to take a break after 30 minutes or so, and take live questions before I move. So keep your questions coming, and we'll take a break, and tackle some of those questions. So back to what is AI. AI is a huge, it's a large branch. It combines some of these smaller branches, and based on who you talk to, it is a combination of mathematics, data science, computer science, and some of the software engineering, right? So people come from 3 or 4 different branches to create this new era of magic. And this slide essentially shows where the popular pillars of AI today as we see it. And by no means this slide is exhaustive. It's barely covering what is popular today and what you hear in the media. And there are a lot of classical approaches that are being missed in the slide. There are a lot of new ones that are not yet popular. So starts with AI, and AI has machine learning. So, and then you have deep learning. The 3 things you would like to take away from this slide is AI is a superset of machine learning, and machine learning is a superset of deep learning. And then there are other branches of AI other than machine learning. For example, symbolic learning. There are a lot of algorithms that were designed pre-2000. Machine learning, took off. And in machine learning, deep learning took off. Before deep learning, support vector machines were popular. Deep learning took off around 2012 because of number of things, mainly 3 things. The data was available, the algorithms improved, and the kind of compute it needed wasn't there before. So these 3 things came together in 2010, 2012, and gave rise to these new wave of research. Just so you know, there are over 100,000 papers that are being published in deep learning alone. And that speaks volumes on the account of its popularity. And before that, people used to use support vector machines, which is another very popular algorithm and has many applications even today. And then deep learning, you go deeper with number of applications in the branches. CNN being the most popular, has number of applications and number of other sub-architectures. And again, RNN has other set of architectures. So what is AI? What do we do with the AI? AI started back in 1959. 1950s, in Bell Labs, there were a couple of scientists who were working on what do we do with the data. Can a computer algorithm look at the data and find something meaningful? And at the time, it was called single layer perceptron. And that also created a spike in 50s where people had their imagination run amok and started thinking about these cyborgs and robots that most of these 60s and 70s movies are based on. But then that era did not go forward primarily because of the data wasn't available. And the kind of data that was needed for these algorithms to be successful simply wasn't there. And so the algorithms that needed to work on the data, they were not thought of. And so it actually spiked, and then the winter came for next 20 years. 70s, there was another one, and then 90s, there was another one. The problem with the 90s spike in AI was that deep learning, which showed promise in early 90s, was figured out that it needs a lot of data for it to become successful. So even though algorithms were there, data was there in some of the branches, but the compute power wasn't there. And so fast forward to 2012, all these 3 things came together and created this new wave that we are sitting in the center of, called deep learning. So what is an AI application? It has 3 things. One is program. The program that extracts the patterns from the data. Okay, it's a program that doesn't change. You write the program today, it's the same program that will be there tomorrow, same program that will be there the day after. It is looking at the data and creating the model, right? Same program, you change the data, the model will change. model, you can also look at the model as a new algorithm that improves over time and with experience. As you're growing and going through the time, you're collecting more data. That means the same program that produced 50% accuracy last year is going to produce 70% today, and 80% tomorrow, and maybe 90% the day after. So the point here is AI does not take a new program. AI program can look at the data, and the more data you feed it, it becomes better over time. And that is the promise of an AI application, where it does not involve human. It can simply look at the world around it in terms of sensors, and then continue to improve and learn without explicit programming or guidance. And that's where the magic is. So like I said, 1959, this term was coined by Arthur Samuel, and then there is another definition back in 1998. Tom Michel gave that definition in his book, which is more apt for engineering-based minds. But not going to go into the details. So how do we create ML apps, machine learning apps? What goes behind into creating these applications? And there are 5 main pillars. One is big data acquisitions. You need to start collecting the data, and that's where the domain expertise comes in. Like if you are in the medical science, you would know how to extract the data from the patients. For example, if the patient is having trouble breathing, today we know that the X-ray would help, or what some kind of imaging would help. That an engineer like me cannot decide. So domain experts, they work into creating the data or acquiring the data. Once the data has been acquired, you go into analyzing the data. Look at the data holistically. Augment the data, cleanse the data, you normalize, visualize, do ton of other things with the data. And once you have the data, that data scientists bless the data, then you start training. You train the model, and the model would be architected according to the problem you give it. And that's where the art of creating and architecting the model comes in. And that's where the data scientists will help you move forward. Once you have the model, you validate the model, meaning you train the model on certain percentage of the data, and then you test it on the data that it's not seen before. And that's called validation. And once you're satisfied, you deploy the model. You take the model out and deploy it as a service or in the chip or wherever have you. So that's how you create an ML application, right? Now, you might have heard from people around and in this domain, what people are thinking. And usually movies and novels that are created that are science fiction eventually do become part of our lives several years down the road. And so the imagination of people and the writers is not far from reality of the future. So for example, look at Matrix. Matrix was in 1999, and the question it posed, are we living in a simulation? The whole world that we are living in, is it just a simulation? And that question is still relevant today based on the people you ask. But one thing that it did is you might have seen you might have watched a scene where Keanu Reeves, Mr. Neo, has a chip at the back of his mind, and that's how he goes in and out of Matrix. So there is a company that is working on exactly the same concept called Neuralink, and they have a 10-year horizon of a chip talking directly to human brain. So people are putting a lot of money into making that kind of progress, and that progress does not come out of nowhere. These ideas that you put in a child's mind, the child grows up with those ideas, and that's the magic his brain is after, and he's trying to create that magic. And that's how the society actually functions. So now back to the point, most of us fear that AI will overcome us. It will take over us. It will take over the humanity, meaning there would be a singularity at some point in future where we all will become some kind of power generating pods for electricity, for the lack of a better word. And my answer to that is not going to happen anytime soon. And like this is one of the hot topics that I get into debates with most people. So I'll spare you with that boring discussion for now. But look at what others are saying, right? I mean, in the society, most of these prominent personalities like Elon Musk, who's sitting on the top of 30 billion, three companies worth billions, and he is on the side of the regulation where I don't seem to agree with him. I'm not as big as Elon Musk, but I have heard his interviews many times, and I think he is wrong. And he was quoted saying that with artificial intelligence, we are summoning the demons. Not true. It's like worrying about overpopulation on Mars. And we have not reached there. It'll take us another 50 years to reach at a point where we should start worrying about singularity. We are far from it. And like I said, if history has told us anything, there are winters and there are summers and there are springs, right? So AI winter will start maybe 5 to 10 years from now, where people would have exhausted all their revenues and would have run into roadblocks, and then progress will stop. Something else will come up, right? The point is, the kind of progress that's needed for us to reach to a point of singularity is not going to happen in next 10 years or even 50 years for that matter. And then there are people like Bill Gates. A breakthrough in machine learning would be worth 10 of Microsoft's. And some of the other guys, there are two sides at this point. One thinks that machine learning, deep learning, AI should be, we should put more resources into developing that. And the other side, which is saying that, we should regulate it heavily because we don't know what it is going to do to us. And so it's sometimes funny and entertaining to read some of these comments that I'm bringing to your attention. Now, back to the industries. Now, this is a number of companies that have started in the last 2 years alone, and just in the Silicon Valley, in the area where I live in. And I can quote the numbers based on the collection here. It's about 7.5 billion, B as in billion, US dollars that have been pumped into the research and creation of these companies alone. And this is a small area, right? It's not a huge whole world. Now you can scale it and see how many people, how many companies are being built at this point. So much resources are being thrown on creating new applications, new devices, newer way of doing the same thing, and more productive ways of coming up with a better solutions using AI. That it's going to change tomorrow, like it or not. So my advice for anybody who's looking at AI sitting on the sidelines is jump right on it. It is the time. It would be part of your life, whether you like it or not. You might not even know in the future that AI is changing you and using you in ways that you don't know. And so better to start right now, especially if you're in the software side of things, which most branches of engineering and sciences are. If you're using some kind of software, you better know machine learning. And the reason is, one part of your job would be to either evaluate model, come up with the model, or integrate models into your product, whatever you're working with. So if you are in the software of any kind, you got to have machine learning as your friend. You can't sit on the sidelines and hope that it'll go away. This is not going to go away. It is here to stay. So some of the applications that you see here, autonomous cars are fast becoming a reality. It's just the humans that are stopping it. Lack of insurance models, lack of licensing, and lack of liability as to whose fault would it be if two autonomous cars or self-driving cars run into accidents, and who would pay the cost and stuff like that. And then personal robots. My personal favorite is chef in the kitchen. So there are a lot of companies that are creating that chef as we speak. And companies like McDonald's are putting a lot of money behind that, because those are the ones that stand to benefit. And some of the news articles that you read today are written by AI. Some of the music that you hear is written by AI. Some of the movies that you would see in future would be by AI. And there are quite a few movies. If you go on and search on YouTube, look for AI movies. those are the movies where the AI has been shown bunch of movies where it has tagged the actors, figured out what the script is, it has written a script, it has edited the movie, it has created the characters that don't even exist. The cast, it has designed the cast based on the pictures for which humans don't exist. They're real looking humans. It has created a human which does not exist on the face of earth. There is no real person behind it. So there are movies, 10, 15, 20-minute movies that are being made today that are completely AI based, and you would not even recognize. You might not like the script because AI is not good at combining multiple things at the same time. But those are sci-fi movies, and if you have time, I would urge you to go and watch one of those movies and decide for yourself. Not for the quality of the movie overall, but can you identify that whether that movie was made by AI or a human? So that would be the test. And if AI is doing, if you rate 5% out of 100% today, it's going to improve tomorrow, right? And that's the promise of AI. Anyway, so the verticals that it is going to impact are enormous. And if I were to quote like over 1,000, I wouldn't be wrong. Anything that you put smart in front of, smart home, smart industries, smart aviation, smart navigation, smart cities, smart infrastructure, smart security, names are enormous. Anything that you put smart in front of is using some kind of AI. And those industries range anywhere from millions to trillions. For example, oil and gas. You wouldn't know the kind of money that has been invested into oil and gas. It's just one data-intensive vertical of AI application. So why now, right? I mean, why now? Why are people so excited about AI? And why is it coming right now? And so there are many techno and socio-economic factors that are bringing things together, and this is becoming a point where things are starting to make sense from the data standpoint. For example, if you look at the CMOS image sensors, the sensors that is embedded in your cell phone, for example, you take pictures, you don't realize who's storing the picture, what is being processed, but the chip behind that is called image sensor, which is capturing all the pixels from the lens and storing and sending it to the processor. So now if you compute in 2020, the total number of sensors are about 8 billion here. And that 8 billion is more than the human population today, right? Why is that number, why is that comparison important? And the reason being, if you assume that on an average, the life of an image sensor is about 3 years, we have about 3 image sensors per person in the world today. The kind of bandwidth that is needed to transport the data from your edge device, let's say cell phone, back to the cloud does not exist today. The kind of bandwidth that is needed is about 10 to the power 20 bytes per second. And total bandwidth, total internet bandwidth of all the countries of this entire planet Earth is about 45 gigabytes per second, 45 10 to the power 9 bytes per second. And so the requirement is 10 to the power 20, and we are sitting at 10 to the power 9. We are 10 to the power 11 or 11 orders away from the kind of bandwidth that is needed. And that will take us another 30 years to catch. Now, what does that mean for the compute industry? That simply means that you cannot transport the entire data back to the cloud. And that means that some of that should be processed on the edge. Most of that should be processed on the edge. And that's where the edge in AI is coming up. NLP is natural language processing. And I'm sure you must have used Hey Google or Hey Alexa or Hey Siri. All of that is NLP, using backward detection and identifying your speech and converting that to sentences, and then just looking for the solution or the answer and giving it back to you. All that is called natural language processing. And biometric sensing. This is the top result. My Google is talking to me. Sorry about that. And the other reason for biometric, for example, socioeconomic factors. The privacy is of super importance. in biometric sensing. For example, your finger, if you have a fingerprint sensor, it is about 125 points that you're storing on the device. Now, if it is password, you can change the password, and you can have the password being stored. You can afford the password being stored on the cloud somewhere. For the finger and the fingerprint, you can't afford that because passwords can't be changed. Your fingerprints can't be changed. You can't lose your finger and create another finger. So some of the things that are coming up are making it necessary that data be produced on the edge. So edge and AI and industry 4.0, right? What are people doing to create those applications? And the slide that you are on shows that is currently being used. The development process that is being used is setting up your hardware, hardware that you like this, that sits in the palm of your hand or a fingertip of your tip of your finger, and these devices are given these AI models. So the process looks somewhat like what you see on the slides. Set up the hardware, set up the software, you acquire the data, you hire a data scientist that will train the model, then you hire an embedded developer that will develop the app and compile the app, then you hire an IoT engineer which will flash the app and monitor the device. So you see there are 5 different engineers that are needed for a company or a person to develop that kind of app. And that is hard. That's a barrier. So we as a company are actually doing our part to reduce some of that. So we are automating all these steps to reduce the pain points in the development so that the magic of AI can be given to a common man and curious minds like you. And so what we have done is created Canvas. What is Canvas? Let's take a look.
Meet Mary. Mary is mute. She learns about a pre-trained AI model that can convert sign language gestures into spoken words and sentences. Mary finds Canvas that lets her put ML model into sensory board. She creates wearable glove speaker. With that, Mary can speak to anyone she likes. Canvas is an online development environment to put ML models into edge devices, including mobile, Raspberry Pi, and Arduino. It lets you update, visualize, train, and compile ML models with Python, C++ notebooks, easily shareable with the world. So, bring out your favorite device and choose a pre-trained ML model and make your device a smart device. With Canvas DIY projects, you can make your home smart with applications like smart switches listening to your voice command, smart door jar alerts, and smart lights. Canvas supports framework including TensorFlow, PyTorch, Keras, and DeepSea. Check out free platform at canvas.ai-techsystems.com.
So we as a company have developed a platform that reduces some of this. And I would like to show you some of the platforms and some of the boards that are used in creating these AI applications. So this is NVIDIA Jetson Nano, the one that I'm holding in my hand. The power that it consumes is about 5 watt plus. And 5 watt is a huge power that no battery can sustain based on the ports it has and the kind of processor it has, the heat sink that is needed. It needs to be plugged in. So it is a good one for the smart factories. But if you go for a smart environment or smart farming, you don't have electricity there. Or even, for example, let's say we are working with NASA and you are designing self-navigation for the Mars, so for the rovers on Mars, then you can't afford to have that kind of power because, again, there is no electricity on Mars, right? So you live on very tiny devices like the one I'm holding in my hand, which runs on battery for almost a year, or maybe like this, which would run on battery for about a week. So there is a variety of devices that are being designed right now as we speak, and the world is going through that change that will change the way we live in. And that's where some of the 7.5 billion number that I gave you is justified as to what kind of research, what kind of innovation is coming to the future of tomorrow, right? And so what we are doing is we are doing our part. Our company essentially is building build the platform, and I have the pleasure of offering you a free access, if so, for all the attendees of this channel. If you go to the link that I am providing right now, bit.ly, and you would see it on my name also. So let me remove my name for the time being and give you the URL. So if you go to that URL, you would see registration form like that. Either you can use that, or you can register with your LinkedIn account or GitHub account. So it's as painless as that. And that platform gives you access to hard disk, some of the compute power, and ways to put the models on tiny devices like this. And we are the first company who's building a platform that lets you bring large models and deploy it on smaller devices for you to create the application. So this one hopefully is useful to the attendees of this webinar. And I would come to that again before this session ends. In the meantime, go ahead and register, and I'll show you an application as to how that works on a tiny device, that would fit in the tip of your finger. Back to how do you, again, develop the applications, right? The AI and the deep learning essentially is divided into 3 different categories with which it is named. The input, you have architecture, and then you have output. And based on that, you call it supervised and supervised learning, reinforcement learning. If you have data set with labels, then you can do supervised learning. If you don't have labels, then it goes into unsupervised learning. If you have environment, then you go for reinforcement learning. And again, the architecture. Is it single neuron, which is typical machine learning, single layer perceptron, not used anymore, deep learning? Anything with more than 2 layers typically is called deep learning. And I've seen networks as deep as 1,200 layers. Now, why don't people create more deeper networks is precisely the problem they face into training and stability of the training. That becomes harder as you create deeper networks. And again, the outputs, whether this is a continuous output, in that case, you will call it regression. If it is a discrete output, then it call it classification. And if you're creating groups, it's called clustering. And if you're reducing the dimensionality of the data set, that's dimensionality reduction. And there are other categories also. The point of this slide is the way you call a certain solution is based on either input, architecture, or output. You must know that. And if somebody's saying classification, you only know one part. You don't know what is the architecture behind it. Is it deep learning? Is it SVM? Is it something else that is giving you that classification? So you need to know more than what you generally read, typically in the media or in a newscast. People who are writing those blogs are not necessarily qualified to write based on the learning they have gone through. So if you want to understand that, I would highly recommend that you go through one of the textbooks that is written on the topic. So what is the AI technology? And this slide again shows the technology that, the main point being machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. And then there are other popular architectures around it. And so, for example, reinforcement learning is a part of machine learning and is a sibling to deep learning. And then deep learning has different kind of neural networks. So what does it take to learn machine learning? So this slide actually shows you the kind of things you might want to learn. It's not necessary to learn all of those things, and not everybody needs to know all of the branches, all of the foundation of the machine learning. So, for example, if you're if you're a data pipeline engineer, you don't even have to know any part of the machine learning and still being called a machine learning engineer. The reason is that your role is essentially making sure that the data pipeline is clean and has nothing to do with machine learning as is. The machine learning, you fit in that paradigm because the output is coming from a machine learning framework and is going to another framework or a compiler, and you are sitting in the middle. You just have to know what kind of data are you expecting and where the data is going, and that's all. And that has nothing to do with machine learning. It has everything to do with data, and that's all. So the point here is the machine learning foundation is built on mathematics and software engineering. In mathematics, it uses 4 different branches of mathematics, in particular algebra, calculus, statistics, and probability. If you are designing a new architecture or new algorithm, you would end up exploring some of these topics. And if you're using some of the designed architectures, you don't have to know any one of what is underneath. And if you're designing or architecting newer ones, then you will have to learn Python, R, C++, or some of the other languages that you choose to write or implement your architecture in. And fortunately, the world has moved on and has given us better tools in terms of libraries and packages. Some of them are listed here: TensorFlow, Caffe, PyTorch, DeepSeek, which you can use without knowing much about the underlying algorithms that are written in these C++ kind of framework or languages. And something that took months 10 years ago is taking few days in 2020. So, and the reason being, most of this has been abstracted at a higher level, where the kind of code that is needed, that was needed 10 years ago, is reduced to 1 line for the most part. And then to make things easier, you have these IDEs that are being developed. One of them being ours. We do offer it for free for the universities and research institutes and we are doing our part to bring the AI community to the next level. And then, of course, once you have the model, how do you deliver it? And we are playing again our part by making it easy to deliver in terms of these small, tiny devices. If you have a large model, would like to deploy that on a tiny device, our platform lets you do that. These are some of the platforms that you would end up using. And let's go back to Canvas. So Dr. Imran or Mr. Piyush, do you have any questions? I can take questions at this point.
So we have some questions here. So shall we take up one by one?
Sure.
Okay, so I'm just displaying some questions on your screen, like this one.
Okay, so how is robotics connected with AI? Robotics is another field in its own. Now, with the advent of AI and the applications, for example, AI can easily process images and videos, right? Now, robots, they need to see the world, and AI gives them that vision, right? So, for example, there is a company called, that name skips my head. It's a Boston Dynamics. So there's a company called Boston Dynamics that are creating industrial robots, and they are using AI in every component of that. And so the way we perceive our world, so go back to how humans see the world, right? You have senses. You see, you hear, you smell, you touch, you feel, and that's what gives you what is around you, right? And if you can put some of these same things in a robot, then and process that information, it can mimic some of the decisions that you would take. And a very good application I have, which I'm very encouraged about, is firefighting. If there is a fire, then some of our brave heroes go inside the burning buildings and help the people in need. Now, only if we could deploy robots which have more um, which can withstand fire to a higher degree. They don't get burns. They are not as fragile as humans, and they can do their work more effectively. For example, our eyes, they don't see well in the smoke, and the building filled with fire has ton of smoke. Now robots can have cameras. If the cameras don't work, you have IR sensors. You can sense where humans might be, where a living or moving creature is, and that is easier for a machine to see. Now we are augmenting some of that technology into head-mounted displays and giving it to firefighters, but I'm a huge proponent of robots. Give that capability to robot and save some brave heroes, put them somewhere else to do a better good, right? So AI is a huge part of robots in the last decade. There are operating systems that are designed to make sure that AI capabilities are inside some of the operating system features, and sensors, right? Sensing, which is not just part of robots, also part of industrial IoT, smart farming. Anywhere you go where the automation is, it is based on sensors, and these are the same sensors that are used in robots. So anywhere you go with sensors, you have data, you would like to decide, AI comes in handy. So it's a huge part of robotics too.
So we have another question now.
Mm-hmm.
How Python
and AI are related to each other. They are related to each other in the same manner that a seed and a soil are related. What I mean by that is you plant a seed in the soil and give it tender love, care, water, sun, and some of the other things, and then you see a plant growing soon. Python is the soil, and you have to use Python and your creativity to write a program using some of the AI frameworks to create an AI model. So not a good comparison, apples and oranges or soil and a seed kind of comparison. They are related in any case.
So one more, sir.
What are the negative aspects of implementing chip in a human brain? A good one. Okay. It's for me. This question is like worrying about overpopulation on Mars. The reason I say that is there is a company. There's a company called Neuralink that is working on a microcontroller directly talking to the brain, and so that would need huge FDA approval and stuff. But in the meantime, what they're experimenting on is mouse, and the mice they're implementing the AI model into a tiny chip called microcontroller, and they're trying to observe if they are able to affect a region of the mouse's brain. And now mouse has very limited set of neurons as opposed to humans, which have anywhere close to 80 to 100 billion neurons, large number. So the current success the only company that is working in the domain, which is Neuralink, has about 1,000 neurons communication. And what are they communicating is not known. If they're affecting the region of the brain, are they transporting that information? It's not clear to me. There is not enough data in the presentations that the company is giving. So I'm not sure if it is to a point where we should start worrying about implementing a chip in the human brain. I can see a lot of the good usage, especially when it comes to medical science. There are a lot of diseases that are brain related and some of the motor related ones. For example, I forget the name of the disease, which most old people develop after 70, 75.
Alzheimer's?
Alzheimer is memory related. but you lose the motor control of your limbs, like your hand or your legs will shake uncontrollably.
Rheumatoids.
I don't know about that disease, but at any rate, what that chip does is it knows the region and it would quickly in real time figure out the signals that are being sent, and that it will cancel those signals in real time. So your hand is not shaking anymore. And same thing with Alzheimer's. It has quite a few exciting repercussions for the human generative or degenerative diseases that it can be controlled. And so I'm excited about those possibilities. Now, can it make you learn? I'm not sure about that. Can it reach to a level where Mr. Anderson's sitting in a chair and an electrode is sending the information into the brain, and all of a sudden he knows how to fly a helicopter? Is far from reality. But the future is exciting. That company is exciting.
Okay, sir. So one more query.
How AI will help us to measure semantic similarity of sentences? That's being done today, actually. There are a lot of algorithms, good ones. And it's not this year or last year. It existed like 4 years ago. So the RNNs are being used, right? LSTMs and GRU and some of these networks are being used to find the semantics of a sentence. And most simple and most popular one is bag of words, which actually creates an n-dimensional space and the connectivity of words with each other. It's a long topic. I don't want to go into the detail, but the similarity of words is very easy with that algorithm, and semantics of the sentence is the next step to that. So it's a solved problem for the most part, and that's how most of these AI writers are writing these articles. Some of the articles that I read in the newspapers today, I can't differentiate if it is being written by an AI writer or it was a human behind it. In topics as hot as presidential election. So, for example, back in 2016, U.S. presidential election, Washington Post had quite a few articles that were generated automatically and published in real time using AI, and nobody knew about that. Now it's a common knowledge today. Pretty much everybody is using that. Now there was a project that came to me 2 years ago, and I would talk about that here. It makes sense because it was based on NLP. So there was a university in Europe that approached us to create a system whereby it'll look at number of papers and create a PhD thesis on a topic that is given to us as one sheet of paper, like 200 words. In terms of problem formulation, you understand what the problem is, and then it is given relevant papers, like close to 10,000 papers. Then it's supposed to come up with a solution to the understood problem and publish a thesis of about 100 to 200 pages. And so this is being creative to a point that the person does not understand how AI and where that is. It's just imagination and creativity of the person who's sitting on the other hand without understanding it. It's not possible today. It'll be at some point. The kind of effort that's needed is humongous. But somebody thought about that, and I was excited that the proposal is huge, and somebody could think about that because they don't want to put effort into doing their PhD. Was awesome. So that was pretty funny to me. And maybe in future we would not have PhDs. We would have AI writing thesis. So that's another example.
Okay, sir. So we have one more question here. Should I take up that question?
Sure. Go on.
Okay.
Which technology is more comfortable for prediction of human sentiment analysis using soft computing or AI technology. I'm not sure what is the meaning of soft computing here. This problem has been solved 5 years ago. I mean, there are a lot of data sets on, if you go on GitHub, there are a lot of data sets that have, and the code also, that can take Twitter data set, can extract that information from Twitter or Facebook posts and some of the other social media posts and classify the sentiment. So that problem has been solved. I'm not sure about soft computing part of that question. So,
Okay.
yeah.
So someone has posted the name of the disease as Parkinson. Maybe.
Yeah, exactly. I was losing that word. It's Parkinson's.
Oh, yeah, yeah.
Parkinson's
So
actually
I.
you lose. Yeah, and the application of Neuralink to solve help patients of Parkinson's would be awesome. Some of these things are, they're magic. That's why I call AI magic, that I strongly believe in. It's just a matter of giving it a data and give you a solution that's as perfect as human. Anyway,
So
so go ahead. So the question from Ramya: in machine learning, which one plays major role or essential part in robotics or ML-based apps, either supervised or unsupervised? The answer is supervised, and the reason being that robotics essentially works on identifying information, right? The information that is relevant to us. So if you're creating a robot, which let's say it's self-navigation around your house, and what it needs to know is what are the hurdles on its way. So it needs to identify whether it can go on a surface or cannot go, or needs to take a turn, right? So with that information, you need to have a data set that is labeled of the entire house. And what that means is you need to teach it through the images that these are stairs because it has wheels, it cannot go up, so that's an obstacle. Find a way around it. Or if it's a paper, then you can go over it, right? So it needs to be shown the pictures of hurdles or non-hurdles. And that's how it'll learn. What that means is your data set has to be labeled. And if it sees a hurdle, it'll try to take a turn and try to find a way around it. And so the AI that you train should have labels, and if it has labels, it's a supervised learning. The way you solve it is that machine learning or deep learning depends on you.
so last question, sir.
Mhm. Dr. Shanti, my question is, I'm doing a research on consumer adoption of AI. What areas do you suggest to research on AI are researchable? What areas do you suggest to research on AI are researchable? Consumer. Um, so, consumer is also a very vast, very large vertical. There are many other markets and verticals that will fit in. For example, smart vehicles, smart infrastructure, smart city, smart home. Um, so if you just take smart home, there are quite a few applications. I think if I were you, I would start with smart home. And there are applications, for example, let's say I have my vacuum cleaner, would like to know if the belt of that vacuum cleaner is about to go bad, and should I order it one from Amazon ahead of time so that my home is not dirty for next week. So there is something called predictive maintenance that chip can be slapped. Do you guys can hear me? I don't hear the.
Yes, yes, sir.
It's
Yes,
doing
sir.
well. Yeah. So the application I'm giving is vacuum cleaner. You can come up with a sticker that has a chip embedded in it, and running an AI model that will sense the vibrations, the kind of vibrations that vacuum cleaner would make in the case of normal operation. And if it deviates from that, then it knows that something is wrong with the vacuum cleaner. And if you create another chip that is close to the belt, it can look at other parameters and tell you that, oh, belt is about to break. You better order a new one from Amazon or some other place. So there are quite a few applications, and some of them being old. For example, thermostat, right? You can control your thermostat sitting in your office. When you start when you start to leave and go, sit in your car to go to your home, the cell phone would know that you're en route to your home and can start the AC or heater, as the case may be, to heat or cool your house before you reach, and open the door for you. And there are these fingerprint sensing locks. For example, when you touch the handle or the knob, then it knows that it's you. It'll open the door by itself. For strangers, the door lock doesn't get open, right? So smart home would have probably close to over 100 or 200 applications I can come on the top of my head. And again, like I said, the imagination is the limit here. So if you were to start with the smart home itself, well, I think that would make it a good research topic.
So one last question, sir. This one.
Can AI help in enhancing the performance of electrical drives? Drives meaning hard disk drives? What kind of drives?
So maybe it's AC drives they are talking about, motorized electrical drives, like the ones we use in the escalators and all.
Oh,
the motors that they're.
Yeah, of course, absolutely. So like I said, and I'll say at a higher level because I don't know enough about electrical drives. I need to understand more. But as long as a problem is producing the data, right? There is, even if it's a human, if let's say somebody is looking at those drives on a daily basis, they would go through some of that on their own, and that's what AI can do too. And AI is much better in terms of extracting that data from and create a pattern and alert you. So all you're looking for is sort of for creating a classification problem out of that data and give you whether the drive is about to go bad, and or one of the parameters of the drive. For example, let's say volt. I mean, the voltage you're giving it, it's not 220, it's 210, and the performance is best optimized at 220. So it will alert you that it is not 220, it is 200 volts. You better take care of that in the electrical line somewhere, and for it to increase the performance. So I don't understand the problem formulation correctly, but as long as you have the data for AI, it can create a model and give you and solve your problem. Well, maybe we can discuss it offline if you are interested. Dr. Imran would have my contact information if you want to reach out. So what I would like most of you to do is, Piyush, was that the last question?
Sir, I have one more, sir.
Okay.
I can't ignore him, sir.
So the question from Kamlesh: what amount of background of game theory is required to work in the field of artificial intelligence? Not a whole lot, unless you are working in the game creation itself. But those two are different things. It's like, what amount of robotics information do I need to work in AI? AI is being used in robotics, but it's not only robotics, it's 1,000 other fields. And if you don't work in robotics, you don't need robotics information. Same thing with the game theory. Unless you're working in the related field, you don't need to know anything about game theory. So short answer, to work in AI, you don't need game theory. Okay, we got to move on. I think it's
Okay,
time
sir.
is
It was the last
yeah.
question then.
So yeah, what I would like you guys to do is to register here, and I will take you with a simple application and show you how to create an application using our platform, right? So with that, I hope you guys are registered and logged on. You should know Python. In this session, we would skip that for the lack of time. You can know TensorFlow or Keras or PyTorch. You can learn it in your time. And we're going to talk about an application, a simple application. How do you develop a hand digit recognition? Like somebody's writing digits, let's say on check or on the back of envelope as zip code or pin code, like where the letter should go. The camera should be able to identify and extract the digits and identify whether this is 20301 or 110049, so that you know whether it's Delhi or some other city and where the letter should go so that it can be binned properly, right? So this was a real application back in 90s that was given to New York University, NYU, and it was given from USPS, United States Postal Service, because they wanted to reduce the cost of delivering the mail, and for them they had to hire people who read and then they would bin the letters, and that binning was costing quite a lot. So what they did was they created the bells that they would pass the letter on, and then on the side they would have bins, just like most smart factory bells, binning bells. And if there was a system that could identify extract the numbers and the digits and bin them, and if it's not able to identify, which is like 2%, then it will send it to the human, and they would reduce the cost by 98%, right? So we're going to discuss that application and use our platform, Canvas, to walk you through as to how do you develop that, right? So I have my Canvas open right here, and I'm going to use PyTorch, but like I said, you can use Keras if you like, and there are other other frameworks that you can use. So our platform that is provided to you guys for free for the universities. We are giving it away for free for the research purposes. So you can use that and experiment with some of this. So I'm giving it some time to start the server again. And all this is done is in the comfort of your browser. You don't have to install or download any software. So what I have here is PyTorch Notebook, which is essentially an IDE development environment for Python. So what I'm going to do is I'm going to run all of that, and we'll walk one cell at a time of this notebook. So, and show you how and what is being done in each one of these cells, right? So for the people who know a bit of Python, this is simply importing the libraries and packages. And for example, import torch is nothing but PyTorch. And this is a Python framework. So you have a Python shell right here, and it's importing the libraries in your environment. The second thing you would do is you download the data set. And this cell is exactly doing that. What is a data set? Data set is a set of 60,000 images, which are used to train the model. So at this point, we are downloading them and dividing them into training data set and a test data set. Now, why are they divided into train and test is because you want to train the model on one data set and then test it on the data set that it is not seen before, so that you can be certain that the newer handwriting that shows up in future is able to do justice with that, right? So this was that, and then we are doing some of the EDA, data analysis here. just doing some of the statistical analysis in terms of looking at the images are real or not. And this is a sample image, which is 0 shown here. And this is how the human has written 0. And all these are supervised learning. This is supervised learning because all these images are labeled. All these digits are labeled. Now we are down to designing a neural network model. And this is a very simple 2-layer neural network model. And with one hidden layer and one input and one output. And that's all there is. It's a matrix multiplication followed by a ReLU, which is a rectified linear unit. Now you have architected your model. You go down and train your model. So this is the training part where it is still training. Now I started it like a minute ago, so it takes some time. We are training it for 10 epochs, and the final accuracy was 97.7%. So if you train it for another 90, that'll be close to 100%. And this plot actually shows you losses. It's a metric that you track to make sure that the error goes down. And once you have it, you evaluate the model on the data that it is not seen before. So what we are evaluating this on is your test data. So see this test loader, it's extracting the images from that and passing it to the prediction. And then that's how we are evaluating the accuracy. And so the accuracy in our case is 97.71. So it is faring well. That means we are satisfied with our model. And after that, let's say if you would like to put the model on this chip and connect a camera on the chip with the port. It's a USB port. And if you connect a camera, then you can put that camera on the bolt. And what the camera will do is will take 1 frame per second. It'll grab the picture, pass the picture through this model, and the model will tell you exactly what digits are on the back of that envelope, right? Once it is identified successfully, then the command is sent to the belt, and then it can bin it appropriately. It's as simple as that. Now you save the model, and this is how you will save the model. The format is ONNX, and then you compile a model. The compilation converts that ONNX model to a C++ model that you can flash. If it's a microcontroller like this one, then you would flash, and if it's a board like this one, then you would download the binary and run it on the board. And so you have the binary. Now we would like to execute the binary and see if it is doing the right thing. So we display the image and then run the model prediction using our executable that we generated with the compiler. So this is the executable, and it's fed the image data, and the image data is written out in a file, and we load the file, and then we predict the digit was 3, which is shown in the image, right? So this is the long and short of how you would write an AI application or deep learning application using our platform. And so I urge all of you guys, right? I mean, if you are working for a university, and this is only for the students and researchers of the universities, we are giving away this platform. If you're working for an industry, don't use this mode. Reach out to one of our engineers, and they will show you the way how to use the platform if you are in the industry. Use the resources, and also if you have something innovative that you would like to discuss further, reach out to one of our engineers. Dr. Imran has the information. We would love to help you guys. And again, keep it to yourself. Don't spread. It's it's approved only for the universities and students who have difficulty affording a new technology. So we are making it possible, doing our part to spread the use of AI, use it wisely so that we can continue to support the community. With that, I think I should stop here. I've exceeded my time by 15 minutes. I apologize, Dr. Imran, was not my intention. Hope the information I've given is useful. Again, reach out to us. If we could help, we would be glad to help.
And definitely, sir, it was a very informative session. and I give the uh, request the Professor Hassan Said to extend the vote of thanks to the entire
Uh,
viewers.
Thank you, Piyush. Uh, Thank you, Mr. Rohit Sharma. Happy to see you here as an colleague also. Unfortunately, Dr. N.R. Kidwai is not here. He gave me this opportunity to listen your lecture, and really, your lecture was very informative and beneficial, not for only the faculty members and students also. So I, on behalf of all the uh, organizing team, I am really very thankful for sparing your valuable time. I know in states that all of you are so busy, so but you spare more than 1 hour, and your lecture was really very beneficial. When I was in Aligarh, this was the first time introduced artificial intelligence and the neural network. So really, your lecture was very beneficial, especially the applications of the artificial intelligence. So thank you very much, Mr. Rohit Sharma. And thank you very much, all the participants, for joining this webinar. And really, your presence is very important, not only to gain, but your presence encourages us to arrange such type of webinars. And thank you very much to all of you, and Dr. Imranullah and Dr. Piyush Charan. Really thankful. Both of you are deserve for special thanks for your efforts and take everything. Yeah, Kidwai sir is here. Uh, Rohit Sharma, okay, Kidwai sir is here. He want to say something.
Thanks, Rohit bhai, for giving such a wonderful presentation. It will be very useful for my students and other participants as well. And many students would like to be in touch with you,
Sure.
and they will call you. And Saeed Saab was 4 years senior to us from the same college, ZH College, who has just handed the mic to me. It has been very wonderful session, and many thanks to you, Rohit bhai, for sharing the experience.
Thank you, Professor Kidwai. Like I said, I'll be happy to help if anybody from university or one of your professors want to reach out to us and spread this. Like I said, the company is focused on spreading the use of AI, and we are doing our part in making sure that it reaches to the masses.
Sure. And sure, people will get in touch with you, sir. Thank you.
Okay, I request all the participants to fill the feedback and attendance form, and it will be open till 3 o'clock. And we'll definitely need your feedback in about this session, so that it can be shared with Mr. Rohit Sharma. And we also want to all the participants who are researchers in the field of AI and machine learning to grab this opportunity to learn some deep learning, machine learning algorithms from Rohit Sharma sir on his platform on Canvas, and so it will be beneficial for your research. So it'll definitely be input to the mankind for the present scenario, because as I've already said through our mails, that machine learning and deep learning or artificial intelligence is a present scenario. It's not the future technology, it's the present technology. So on that note, I end this session and request all of you to give your valuable feedbacks. Thank you so much.
Thank you, sir.
Thank you, Piyush. And like I said, I'm seeing some comments here. Rajiv Banerjee, Nidhi Chawla, Muzaffar Ali, Abdul Kalam. Like I said, and if you guys are interested, feel free to reach out. Dr. Imran and Professor Kidwai would have my contacts. and then
Sure.
we would have one of our engineers help you out. Take advantage of the opportunity, and I strongly believe AI is here to stay. So get started sooner. With that note, thank you, everybody.
Thank
Thank you,
you.
sir. Thank you.
Okay, sir. Thank you.
Bye.
Thank you, Rohit.
Bye,
Bye.
sir.
Good day, guys.
Bye.